Hello, this is Mrs. Scarpel with topic 3.14, polar function graphs. So if you remember from topic 3.13, for polar functions, we can identify the ordered pairs as theta r, where theta is the independent variable, r is the dependent variable. On the AP exam, you might see the following type of phrasing to introduce a polar function. The graph of the polar function r equals f of theta, where f of theta equals 3 minus 3 sine theta, is shown in the polar coordinate system for 0 is less than or equal to theta is less than or equal to 2 pi. So you're generally going to be given some domain restrictions because, of course, it's periodic. And I do want to preface what I'm about to do, you will not be asked to do on the AP exam. You will not be asked to provide graphs on the AP exam because all polar functions are going to be on the multiple choice section. So what I've done here is, if you were asked the question or given the problem of sketching the graph of r equals f of theta, what would probably be easiest for you at this point would be to complete a table with those radian measures that we have on the unit circle. So our function was r equals 3 minus 3 sine theta. I've gone ahead, I have found those values. So when theta is 0, sine is also 0. So that's why we have a radius of 3. Or a radian, or a radius of 3. At pi over 6, sine is 1/2. So if I do 3 minus 3/2, I get 1.5. So hopefully you're seeing how I'm getting these numbers. And keep in mind, pi over 6 isn't that first marking on our polar coordinate system. It's actually the second. It goes pi over 6, pi over 4, pi over 3. So at pi over 4, let's see here. Yeah, pi over 6. Oh, I haven't labeled that yet. Pi over 6 is going to be 1.5. So that's probably going to be about right here. Pi over 4 is almost 1. So probably down here somewhere. And then at pi over 2, we're at 0. So we've got the start of something that looks like this. Might be easier for me to go from left to right as I sketch this. So we've got a curve that looks something like this. There we go. Let me take off the extra. Then we see that we have some symmetry happening. We have like the same kind of curve as we continue our radian measures between pi over 2 and pi. So at pi, we have that radian measure of 3. And at pi over 4, it was almost 1. So 3 pi over 4 is almost 1. Let's see here. And we were at 1.5 at the pi over 6. So we're going to have a curve that looks something like this. And then after pi, it's still symmetric, but in a different way. We see we have a maximum of 6 at 3 pi over 2. And what's going to happen is we're going to have a curve that looks something like, now my graph is really off. Here we go. Maybe I'm getting it now. But it should look somewhat heart-shaped. We call that a cardioid, because the shape of it, it falls into almost a heart-like shape. So this is something called a cardioid. And again, this is just a sketch. I haven't plotted all my points. I haven't made it very perfect, But this is the type of curve we could see on a polar coordinate grid or polar coordinate plane. So, as I mentioned, you are not going to be asked to sketch by hand on the AP exam polar graphs. You will be expected, though, to solve problems using a graph or a portion of a graph for a given domain. So if we take a look at example 2 here, as you can see, it's like we have 3 petals. And we're looking for which of these 4 functions could be represented by this graph. And we're going from the domain of 0 to 2 pi. Well, the easiest thing for me to check is, well, if theta is 0, what's my value going to be? So if my value of theta is 0, I'd end up with 3 times sine of 0, and sine of 0 is 0. I'm just going to write this as 3 times 0. Sine of 0 is 0. So that's going to be 0. Likewise, negative 3 times sine of 3 times 0. Get rid of that parenthesis. I don't want to have too many of them. 3 times 0 is 0. But cosine, if I put 0 in for theta on a cosine is actually 1. So cosine of 0 is actually 1, excuse me, and 1 times 3 is 3. And if I were to do it with the negative 3 times cosine of 3 times 0, I'd be at negative 3. But I don't see any values here at 3 or at negative 3. So I can rule out my cosine values pretty easily. As I go around, I see that I have a value of 3 at pi over 6. So what I want to do is I want to try to find my value of my function using pi over 6 for theta. So if I try 3 times sine of 3 times pi over 6, that's the same thing as saying 3 times sine of pi over 2. Pi over 2 has a sine value of 1. So this would become 3 times 1, or 3. So if I look at my graph, we used pi over 6 for theta. When we simplified, we got a radian value of 3. So my answer is going to be A. If I had tried it with B, I would have had a measure of negative 3, and that means that my graph would be over on the opposite side of my polar grid. So when you have a negative R value, you go backwards from your radian measure that you used. You go opposite in direction. Let's take a look at example 4 because example 3 is just more of the same. With example 4, we are given a portion of the polar function r equals f of theta, where f of theta equals negative 3 sine theta. Now, when they give you the actual function, it might be a good idea, and this is as I was preparing for this video, and I worked through all the practice problems, this was the tool that helped me the most, was to make a sketch of that function. So negative 3 means I'm going to have an amplitude of 3. I don't have any vertical shifting. Negative, however, means that it will be starting by decreasing and then increasing. So here's 2 pi because my period here, because it's just theta, is going to be 2 pi. So my graph is going to look something along these lines. So as I look at my graph, and this point right here is pi. So as I look at my graph, I'm going to be going from a negative 3 value, which is occurring at, it happens at, I can think of this as being -3 at pi over 2. This would be -3 down here, bringing me up to a 0 at pi. Or I can think of this as, no, that's exactly what I want. If at pi, if I look at at pi over 2, excuse me, pi's over here on the left. Pi over 2 would be up here. Pi over 2, according to my sketch, would have me at -3. So instead of being up here at the top of my polar graph, it's going to be at the bottom. So this, if I wanted to write some coordinates for it, remember we're writing them as theta r. This would be pi over 2, -3 is the ordered pair at this point. Then what happens to the graph is it becomes less negative until we get to 0. So we're becoming less negative as we follow these values after pi over 2. Negative would put us over in this fourth quadrant until we get to 0. So since I'm going from pi over 2 to pi, that's going to be my answer here. It's going to be B. And this does take some practice. This does take some getting used to thinking about how these graphs will work. Number 5, we're given another portion of a graph. This one, however, we have a different length for our period. So we're still 3 and 3. However, this time we're thinking cosine. So we're going to be starting at a maximum or a minimum. Because it is positive, I'll be starting at 3. But my period is going to be 2 pi over 3 because my B value is 3. So if I sketch out, here's my 2 pi over 3. So it will hit its minimum at pi over 3. So one period of this cosine function is going to look like this. This should have gone through 2 pi over, no, this is 2 pi over 6. This would have been 3 pi over 6 or pi over 2. So as I look at this graph, at 0, I'll be at 3. And then my radian measure is decreasing until I get to pi over 6 here because that's halfway between 0 and pi over 3. That's going to be pi over 6. So from 3 to pi over 6, we're having a decreasing radius till we get to 0. So that is going to be A is 0, B is pi over 6. And that's what we're looking for. We're looking for the values of A and B, where A is less than B. But A could be equal to 0. So that's why we can start with A equals 0. Again, we're just thinking about, okay, at 0, our radius is 3. At pi over 6 is the first time we get to 0. If we take a look at example 6, and this is our last example from the notes, I'm again going to sketch a graph. This time it's 6 cosine 3 theta. So again, we're going to have that radius of 2 pi, or that period of 2 pi over 3. And we're also going to be restricted to the domain of pi over 3 to 2 pi over 3. So I'm just going to sketch that portion of the graph. So we have an amplitude of 6. We're starting at the maximum. We're starting at 6 because it's positive. My period is 2 pi over 3, so I will be at my minimum at pi over 3. And this is what my curve will look like, something like this. Just a rough sketch. What we are looking for, we're looking between pi over 3 and 2 pi, which sections of our graph will fit this. One of the pieces is the portion in quadrant 3 from C to D. So C, I can think of this as being, because we're restricted to pi over 3, this is pi over 3, but it has a -6 reciprocal. Or I shouldn't say reciprocal, has a -6 R value. So pi over 3, -6. So this point down here is my C. And then I'm going to 0, so this must be a D value. And then it increases, so that at 2 pi over 3, we're in the positive. Well, A here is located at 2 pi over 3. And it has an R value of 6. A is located at 2 pi over 3, and it has an R value of 6. So that must mean we're going from D to A before we start decreasing again. So D to A in quadrant 2 is what we're looking for as our final answer. So again, this will take some time. This will take some practice. Like I said before I recorded this video, I did all of the examples in the notes, plus all of the homework problems, just so that I could try to explain this as clearly as possible. Do not hesitate to ask questions. Do not hesitate to sketch graphs. Do not hesitate to even just go ahead and find the values like we did on number 2. This really is going to be a practice in using your multiple choice responses in order to find the answer to your problem.